Hello, my name is Sunny Pathak. Today we will go to start very important topic, which is a relations and functions. So now the first question is, what is relations? Relation means a pair of two things. It's very simple definition. Okay, like it has very written the collection of order pairs. That's it. Which do not need any kind of a confusion. Just combination of two things is known as relations. Like we have a given example here, mathematical terms, 2 minus 5 and minus 2, is it? So that's a 5 is an x coordinates and minus 2 is a y coordinates. So this is a relation, is it? So okay, completely understand how do we represent. Suppose if we have so many pairs, is it? So many pairs, you can write a curly brackets, is it? Look, so we have given one in a proper form: minus 2 1, minus 2 3, 0 minus 3, 1 4, 3 1. So this particular brackets means relations are set in the curly bracket. So that is it. These are the relations. So we have, you can say, set of 5 relations: 1 2 3 4 5. Is it? So need to be move ahead. Okay, so this can be represented in a table also: minus 2 1, minus 2 3, 0 minus 3, 1 4, 3 1. Is it? Similarly we can represent in the graph also, like minus 2 or 1. So minus 2 means this one, a minus 2 or 1. That's a minus 2 1, minus 2 3, minus 2 and 3. Similarly 0 minus 3, 0 and minus 3 means go down. 1 4, 1 4 is here, 3 1. So 3 has a x elements and 1 is a y element. So this means, so I hope you have understood, because you have already read this thing in a 9th and 10th standard. So okay, this can also represent in the Venn diagram also. So Venn diagram, how do we represent? Simple, do not go to repeat anything, like minus 2 0 1 3, or 3 minus 3 1 3 4. Like if I look at from here, yes, so minus 2 minus 2, it has written 2 times, means minus 2 has a 2 relation with it is a with 1 and it is a with 3. But at the time of Venn diagram, we will not go to repeat this. So minus 2 has a 2 relation, means which is a 1, and 1 has a 3. So similarly we have just represented. So minus 2 0 1 3, the element of x. Similarly minus 3 1 3 4, the element of y. Is it? So now there are two important point after the relation. Okay, which is a domain and range. What is a domain and what is a range? So the set of element of x, which is known as a domain, and similarly the set of y is known as a range. Like for example, minus 2 0 1 3. Okay, this is the set of x, which is known as a domain. If you move ahead, minus 3 1 3 4, the set of y. Okay, so it is known as a range. Hope you have understood. So okay, move ahead. So you can see an example, means definition of the domain. So the domain has clearly written. I am going to, yes, the domain is the set of all x or input values, is it? Similarly the range of the set of y or output values. So again the same example is written here, is it? So look, this is the relation we have given. Okay, and the domain and range are written here separately. Minus 2 0 1 3, is it? Similarly, if you look at here in the range section, so 1 3 minus 3 4, because 1 is going to repeat, so I have not written here. Domain part have understood, range part also have been understood. Okay, the relation topic has been over. The relation has two things. Again I am going to repeat, relation is a pair of two things, that's it. Okay, and relation has two things, one is a domain, another is a range. So domain means the set of all the x elements, range means the set of all y elements. Understood? Now we'll talk about the function. So function means, so it has written a function is actually a special kind of relation. Okay, just need to understood this one. A function is actually a special kind of relation. It means, okay, means all function and all relations are not a function. So means some function are relations. Okay, so we have given here every x value must be associated to only one value, one y. This is very important, line. The element of x must be associated to only one value of y. If we have only the one value of y, which is known as a function, otherwise it is not. We have better understood with an example. Like we have given an example, minus 3 has, this is the element of x, has a one relation with 7, minus 1 has a 5, 0 has a minus 2, 5 has a 9, 5 has a 3, means the element of 5 has a 2 relation. The definition says here, every x value must be associated to only one y value. So means, but if you look at this example, so 5 has a 2 relation, is it? 5 has a 9, 5 has a 3. So the relation function, the relation that it is a relation, but it is not a function. Hope you understood. So we have a further example, minus 2 0, minus 2 minus 1 minus 2, 0 3, 4 minus 1, 5 minus 3. So if you look at this example, so each element of x has a unique value of y. So this given example is a function. Okay, so move another. Okay, we have if you look at this example, 1 5 1 5, 3 minus 8, 3 minus 8, 3 minus 8. So do not need to get confused. Actually they are repeating this part. Okay, so look, so this table can be represented, in this form. So means if you look at this here, because 1 5 1 5, it is the same thing, 3 minus 8, 3 minus 8, 3 minus are the same thing. So 1 has a 1 relation, 3 has a 1 relation. So this is also a function. Okay, so move ahead. Okay, we have so many examples. 5 has a relation to 7 has a 0, 8 has a 1, 10 has a 2. Now you are thinking about the 2. 2 is making relation with means 5 as well as 10. But if you look at the example, so definition of the function. Definition of function says the element of x must be associated with only one with only one value of y. So here the 5 has a only relation with 2, 10 has a only relation with 2, 7 has 0, 8 has 1. So mean the definition, here we are talking about domain, not a range. So each element of domain or x has a one unique relation with y. So this is why it is a function. Okay, hope you understood. So now another example, domain. 1 has a minus 2, 2 has a minus 2, 3 has a minus 2. So again, if you talk about, this is also one of the very good example. So 1 has a only unique value of -2. Just only think about the element of x, not y. So it is also a, like it has also written here, it is a great example of function as well. So this is a function also. So now we have another example, -8 7, -1 9, 0 1, 15 and 9. But look, if you look at the 15, so 15 has a relation with 7, 15 has a relation with 9. What do you think? Is it a function or not? Yes, it is not a function. Okay, why? Again, if it look up, if we talk about the definition, so definition says the function, each element of x must be associated only one value of y. So here 15 has two values, so it means it, you know, it doesn't come in our definition of function. So the given example is not it's not a function. Okay, it's must have example. So it has written also, an element of domain is being greedy, means 15 is greedy, means you must have only one, you must be associated only with a one. Okay, or you can say if you have one wife, so the domain, this is not as a function. But if you have two wives, you are not in the form of the function. Well, we are move ahead, more example. There is another example, is the relation expressed in the mapping. Okay, so 5, so look, the 5 has so many. So if I again give an example of husband wife, so husband, a man can marry, but as a Hindu marriage act, he is allowed just go for the marriage only one woman. Okay, but here he has already married with 4 women, so it is not a function. I hope you have understood. So you can, like in a real example, you can say, so husband wife, a man is allowed to marry only a single woman, so it is not a function. If he has two wives, more than two wives, okay, more than two wives, it's not a function. So this example also very good example, it is not a function. Okay, so one of the another example. So here again, if you look at the domain, 1 has a relation 5, 2 we don't know, 3 has a relation -3, 4 has a relation 14. So this is also very important example. Okay, if I look at, okay, each element, but each element 2 is not extended, each element except 2 has a one relation. Okay, so function, okay, but initially when we discussed about the relation means that we must have a pair, each pair. So if I talk about the 2, if you go down, look, 2, okay, 2 does not have any relation, or 2 does not have any pair. So it means it's neither a relation nor a function. For the function, it is very important, first we must have a relation, then we talk about the function. So here we cannot, so the given example is not a relation, neither relation or nor a function. Hope you may have understood. If you haven't, if you have any confusion, you can go through again and again the video. Thank you very much. Hope you have understood. Have a great day.